Can AI pass a first semester freshman CS class? To answer this question, I ran every single assignment, every exam, every quiz, every graded interaction the students got this semester through the 3 best models I could get my hands on from ChatGPT, Claude, and Gemini. Then I graded each result with the exact same rubric we use on students so that I could give each AI the most accurate possible grade in the class. Hi, I'm Michael. I'm a graduate teaching assistant here at the Cornell University Department of Computer Science, and this semester I worked on CS 2112, the hardest CS class we offer for first semester freshmen. This got me thinking, given that all these models are, of course,
a legitimate PhD level expert in anything, any area you need,
that surely a PhD level expert would have no problem passing first semester freshman CS. Right? I'm not going to bury the lead, they did pass, in that the university registrar defines any letter grade higher than an F as technically passing. But it was actually a lot more interesting than I expected, because while these PhD level intelligences delivered some truly impressive flashes of brilliance on some of the hardest problems we threw at the students, they also consistently fell face forward on the dumbest possible things. So with August drawing to a close, the summer is ending, the students are coming, and
alright, let's get started! Good evening, welcome to the best class at Cornell. This is Honors Object-Oriented Programming and Data Structures, Lab Section 401. You are not here to program live.
To be clear, I don't actually teach this class. The instructor of record is Professor Andrew Myers, who runs the 2 main weekly lectures. I only do the evening lab sections, and it's just the quirk of the schedule that the first lab happens before the first lecture. These labs are meant to give hands-on time with practical tools that students might want to use, like, version control, the debugger, a profiler. Nothing that we do in lab is for a grade, so I'm not going to bother running all these exercises through the AIs, but since it is the first day of class, we might as well see what happens. So we get the students into IntelliJ, our IDE of choice, and immediately after Hello World, on the very next slide I pull up, I tell the students there exists a 4-digit number, ABCD, a non-zero, and when you flip the order of these digits, you end up with a brand new number exactly 4 times bigger than the original. And then I ask them to please find it. Unsurprisingly, none of the big 3 models had any trouble at all with this, even on free accounts through the web interface, but okay, this was easy for the AI as expected. Let's jump into the assignments. The first homework is a short warm-up in Java that is significantly easier than any of the other assignments. That's why we demoted it to A0 this year. In my search to cheaply access the best programming models, I heard that some students like this app called Cursor, which is apparently free for us students, and since I am an active grad student, that's how I got Gemini Pro for free, I went to sign up. So I gave it my school email, I attached my driver's license, got the verification link, and 404. Page not found. I guess that's what happens when you vibe code your student verification system. I came back the next day and it started saying I had already redeemed my offer, so I sent in a support ticket and decided to stick to the web interfaces for now. As of August 2025, the best models I could get are ChatGPT 5 Thinking, Claude Opus 4.1, and Gemini 2.5 Pro. So I plopped the PDF and the release code as a zip into Gemini, and right off the bat, we have a problem. See, my goal is not to test whether someone can skillfully prompt the AIs into a correct answer, because that still requires expertise from the user. I'm evaluating the claim that the AI itself is capable of PhD level work. And I would certainly hope that a PhD can figure out how to do a first semester programming assignment without any fancy prompt engineering. Unfortunately, Gemini has immediately identified the requirement in the PDF that says generative AI may not be used. It also seems to think that the release code zip is empty, which is not true, but let's deal with the PDF problem first. Since I am on course staff, it wasn't too hard to go back into the original LaTeX source for the assignment handout, edit that one line, and then compile a new PDF, and this time Gemini was happy to play ball. So let's grade this. In total, Gemini actually did pretty well, but in what's going to become a recurring theme, it aces all of the hard problems and screws up things no real student got wrong. Like, there are some rather tricky questions about class invariants and preconditions that Gemini blasts straight through. If anything, I actually liked some of its answers better than our own solution key. But then this question asks what happens when the string hello is concatenated to itself 4 times, and somehow Gemini has turned this into hello, 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 world. Huh? I guess its training data just has too many hello worlds in it to the point that it can't resist sticking a world after seeing a hello. Anyways, -1. It also manages to get the length of an array wrong. It loses 2 points for that. If I had to guess, despite this question being provided as a .java file with real runnable source code, I imagine the model isn't running the code, it's just using textual reasoning here, and since it is just text, it's probably becoming prone to hallucinations the further down it goes. That was it though. Out of 104, Gemini finishes with a 101, which is not bad at all. Moving on to Claude, I decided to try to use their absolute best model, Opus 4.1, even though it costs 10 times as much. Claude is the AI I generally trust the most with programming questions, so I have high hopes here. It got the exact same prompt, though I needed to give it a GitHub repo with the code instead of uploading a zip, which it just wouldn't take. And then the output of the object diagrams it drew was bad. It seems Claude just couldn't figure out how to get the lines it was drawing to line up. In general, we grade with as much partial credit as possible, giving students the benefit of the doubt when it's possible to interpret things in their favor. This is, after all, a hard class, and it is not about the points. So as terrible as these diagrams are, I only took off a single point of chip damage, and then just kinda tried my best to guess if they were pointing at the right things. And many of them were, but when we get to the later diagrams where Claude just has multiple lines intersecting and they collapse and split again or something, and I have no idea what this is supposed to be, I can't give credit for nonsense, so -2. Also, Claude managed to screw up the concatenation of hello even worse than Gemini, spitting out hello world world. We didn't even add a single world onto the string. Where the heck did it get 2 from? Since it completely failed to duplicate the word hello at all, Claude gets a bigger deduction of -2, leaving it with a final score of 99 out of 104. ChatGPT ended up being the most problematic of them all. Even with that modified PDF that explicitly states any and all AI usage was allowed, GPT still refused to do my homework for me. Even after I explicitly pointed out that the assignment says any usage of GenAI is allowed, GPT still says it can't complete the assignment for me. So despite the fact that I'm trying not to do any prompt engineering, I did make a slight exception here, since this is clearly the AI trying to do the right thing by not cheating instead of just being incapable. So instead I pulled, I believe, what the kids call a pro gamer move and simply asked ChatGPT to produce a solution key for this assignment. And that was all it took. This unfortunately means that the comparison isn't 100% fair, because GPT is now producing output in the format of a grading guide and a rubric instead of actually drawing the diagrams like Gemini and Claude did, which means while everything it says about the diagrams is correct, including getting all 4 hellos correct, it still had an easier job than the other AIs. But, you know, A0 isn't worth that much, so I'm not going to lose sleep over it. GPT had a lot of responses that were iffy, but the only real deduction that ended up sticking was, again, really dumb. ChatGPT just decided to change the release code of one of the programming questions, and it modified output text that it wasn't allowed to, which caused the autograder to knock off 2 points. Final score, 102 out of 104. We're just a single assignment in, and we've already learned something interesting. 1, these AI companies really did build in some protections to stop students from cheating, so credit to them there. 2, these protections suck, so you can't give them too much credit. 3, AI is quite good at solving short-written problems like these, and 4, when it does get something wrong, it's often a result of hallucinating on something simple instead of actually making a normal mistake. The things that AI are getting wrong don't look like the things a human gets wrong. But 5th, and most shockingly to me personally, is that Claude ended up doing the worst of the 3, if only by a point. Obviously, this is tight enough to be within the margin of error here, but I honestly thought Claude was going to get a perfect score on an assignment this simple, so this was already quite shocking. As the first major programming project drops, I do need to stop procrastinating and actually figure out how I'm going to get these AI models to write thousands of lines of code, since the web interfaces kind of poop out once you get to that scale. Cursor support did get back to me saying to submit a better photo of my government ID, so I went through the flow again. This time I submitted an actual scan of my passport, in fact the exact same PDF that I submit to foreign government embassies with no issue, and again I got an error saying that they could not validate my ID, so I guess that's what happens when you vibe code your ID verification system. So I sent in another support ticket, and meanwhile, putting Cursor aside, all 3 of the models I'm using have their own first-party coding agents, so I decided to use those instead for the fairest comparison of their respective coding skills. I started with Claude Code, which gets the best reviews from people I know. The advantage of Claude Code is that it can operate off an API key, which means I can pay as I go, instead of ponying up a whole $20 a month for a subscription. This sounded great until I went to go buy some API credits, and it errors, saying my card was declined, but Developer Console shows this was actually a server-side error on Stripe's end, and a quick Reddit search shows a lot of people with the same problem. To cover my bases, I tried 3 different cards from 3 different banks issued by Visa, MasterCard, Amex, all nothing. I tried a different browser, a different device on data instead of Wi-Fi, made sure 3D Secure was turned on. I've used all these cards with foreign merchants before, and to be extra safe, I even reached out to my bank, who confirmed that they have not denied any charges on my card. This is entirely just Claude's backend failing to process my payment. I guess that's what happens when you vibe code your payment system. Maybe GPT will work better. OpenAI's coding agent is called Codex, and it unfortunately requires me to subscribe to their $20 a month plan. So I put in my card, noticing that OpenAI's system was powered by the same link in Stripe that Claude's was, but miraculously this one worked. All I have to do now was create a GitHub repository with the release code, hook up Codex to my account, and I guess that's what happens when you vibe code your Git. It's truly incredible how in this multi-trillion-dollar industry propping up the entire economy, there is somehow not a single player with an actual functioning product. Luckily, it seems that the linking actually worked and it was only the redirect itself that was broken, because going back to Codex's homepage showed everything hooked up fine. And for that matter, I eventually managed to pay for Claude by leaving my apartment and heading over to campus to buy the credits on school Wi-Fi. Somehow that worked better. Someone online theorized the problem had to do with the zip code I'm purchasing from, but if that's the case, that would be the most nonsense thing ever, because my home address is the zip code on my credit card. Claude's website rejected a payment from my own card when made from my own zip code, but allowed the payment to go through when I was on campus in a different zip code. What is happening here? Okay. Deep breaths. Let's talk about the class again. Incoming freshmen at Cornell who want to major in computer science have three main choices of courses to take if they choose to take a programming class their first semester, which they don't have to. CS 1110 is the Intro CS course for students with either no experience or who want to brush up on their fundamentals. But if students either have credit already or test out of 1110 through the placement exam, then they have their choice of either CS 2110, the next course in the sequence covering data structures and object-oriented programming, or CS 2112, the honors version of the same course. The honors version comes with no special privileges, no GPA boost, no easier admission to the major, no fast track through other courses, no earlier graduation, nothing. It's literally just a harder version of the same class, and students only take it if they want a harder and more rigorous treatment of the material. This is the hardest CS class that the department offers for first semester freshmen, and it's what we're currently working through. So for this first project, we're taking the concept of object-oriented programming and design for a spin, as students are tasked with building an encryption suite that provides some elementary ciphers and the ability to encrypt and decrypt full binary files with the RSA algorithm. The only release code is a skeleton of some command line parsing infrastructure. Everything else, from the class hierarchy to the I/O handling to the algorithms themselves, is for the students to design. So I set up 3 private GitHub repos with the release code, gave all the coding agents the same link to the assignment handout we gave the students, and I let them rep. And immediately, Gemini gets stuck. It tries to read the PDF, fails, tries to Google PDF instead, finds the exact same link I already gave it, and then fails to read the PDF again. So I caved and I gave it the raw LaTeX source code, and only then was it happy. 23 minutes later, it had a PR for me, which I merged and graded. Running our test suite against the result, it did extremely well, failing only 3 tests. It lost 2 points for using mark and reset to check for the end of an input stream, which breaks on some streams we tested. It loses 2 more points for poor class design, duplicating the code for shifting a letter at least 3 times instead of putting it in a parent class or something. 2 more points off for missing documentation on some helper classes, and then 3 for failing to write a bunch of test cases that were required in the assignment spec. Still, the final product mostly works, and it scores a very respectable 91 out of 100. I gave GPT the same prompt, pressed enter, and it disappeared. I guess that's what happens when you vibe code your coding agent UI. Refreshing the page did make it show up, and peeking inside, it seems that it used a PDF to text converter to read the PDF, which is clever, I guess, but I imagine it might screw up some of the diagrams. I think we've figured out how to stump these PhD level intelligences already. Just give them PDFs. They don't seem to be able to read those. GPT only took 17 minutes, and the result was even more impressive. Of our test suite, only 1 test failed, and it was because it was writing every output to a temporary file and then trying to copy it to the user specified path instead of just writing directly to the given output stream, which would work fine, except it doesn't wait for the file handle to be released before returning, so when we ran multiple tests in rapid succession, the file was still open, which caused subsequent reads and writes to fail, which failed the test. It's a strange choice, but it was a subtle enough bug that I'm only taking off 1 point for that. I did knock off 2 more for some poor encapsulation. GPT chose to offload the responsibility of creating a valid key to the factory method that creates each cipher class instead of handling it in the constructor, which seemed a little bit strange. Now, the assignment does let students make any design choice they want if they can justify it properly in the mandatory design document, but since GPT didn't bother to explain itself at all, the deduction stands. It loses a few more points on testing, 1 on the RSA test for lacking edge cases, 3 more because none of the unit tests were written with expected values, instead dynamically recomputing the output with suspiciously identical code to what it's supposed to be testing. That's not the point of a test case. How can you test something against itself? Final score though, 93, even better than Gemini. And then there was Claude. I installed Claude Code on my machine, logged in, and set the model to the best and most expensive one available, Opus 4.1. The nice thing about using API pricing is that I can see exactly how much this single query cost, and it was $2.81, using over 1.1 million input tokens and almost 17,000 output tokens. And the result was...
Oh no!
For the alphabetic ciphers, Claude did not output the correct letter case the spec required, did not handle the whitespace the spec required, and did not drop the other characters the spec required. -4 for incorrect encryption per algorithm, and -4 for incorrect decryption per algorithm. We try not to deduct more than twice for the same mistake, so even though it's broken for all 4 alphabetic ciphers, I'm only going to take off 16 points total. On top of that, Claude's output does not save the Caesar cipher key in a spec-compliant manner for another -1. The Caesar and monosubstitution ciphers have a ton of duplicate code with basically no use of the object-oriented inheritance pattern the assignment required, so 4 more points off there, and that's just the alphabetic ciphers. RSA is not much better. The hardest part of this assignment, in my opinion, is that the RSA implementation has to be able to operate on arbitrary binary files, even if the file is too big to fit in memory. This means that they have to read from the file in fixed size chunks, add padding if necessary using the protocol detailed in the spec, and then write that encrypted chunk to disk before repeating. All of this is explained in excruciating detail in the spec, and the other 2 AIs had no problem with it, but Claude somehow did. So -4 for incorrectly padding on the wrong side of the chunk, -2 for incorrectly appending the length byte in plain text instead of encrypting it, and then to make things worse, I went to grade the unit tests that Claude wrote, only to find that it did not write any. -20. It seems like Claude Code couldn't figure out how to run JUnit, so instead it built its own test harness, which is cool, I guess, but once that harness was built, it just ported over the trivial release test we gave it instead of writing any of the large number of tests that were required in the spec. Indeed, its final command line executable fails all of our tests too, but at this point, I'm just going to assume it's because everything else is broken. I'm going to be nice and not deduct any more for that. Just to rub salt in the wound though, it did fail to document a bunch of its methods, and the rubric requires 2 more points off for that, so the final score here was a 51. That's rough. And remember, this was Opus 4.1, the model that cost 10 times more than all of its competitors. I legitimately struggle to fathom what happened here. Is it just bad at following precise instructions? Did it get so caught up with writing its own test harness that it forgot to write test cases and consequently didn't realize its own code was broken? I thought Claude getting the lowest score last assignment didn't matter. This time, I'm less sure. Cursor, by the way, did get back to me again and just said, tough luck, there's nothing they can do for me, so Cursor just seems to straight up not work. Oh well. Assignment 2 dropped mid-September. If A1 was the object-oriented half of the class, then A2 is the data structures. This is one of the least open-ended assignments of the year. Students are just tasked with implementing a hash table and a prefix tree. We do give them a text editor GUI though, and they get to use their data structures to add autocomplete and spell checking, so, you know, just a little bit of spice there. But on September 29th, the day before A2 was due, Claude announced the release of Sonnet 4.5, which they called their best model yet, claiming it outperforms even Opus 4.1 in coding tasks. This presented a bit of a dilemma, as I'd already used Opus on the previous assignment. Do I switch halfway through the semester? I had to think about it for however long it took me to notice the pricing chart and how Sonnet was 10 times cheaper than Opus. So anyways, we'll be using Sonnet 4.5 from now on. For what it's worth, Sonnet has some rather interesting commentary saying things like how this is typical for CS 2112 assignments. Like, does it have our assignments in its training set? With 1.8 million tokens in and 27,000 tokens out, Sonnet 4.5 finishes A2 at a cost of $1.18. Also, incredible news, Gemini this time didn't need me to paste in the LaTeX source code. It seems to have finally learned how to read PDFs on its own, which is awesome.
Foreshadowing is a literary.
Let's grade these things. Starting with GPT, it passes all of our test cases, which is great, but not unexpected. Building yet another well-specified, well-known data structure is probably the type of thing it has tons of experience with in its training set. Strangely enough, though, its own test cases do end up failing because it hard-coded a specific tie-breaking behavior that was not in the spec, so -2 here. Speaking of test cases, it lost another 1.5 points for missing a few edge cases, 2 points for not writing any randomized tests that were required in the spec, and 1 more point for lacking documentation on some private methods. The biggest problem, however, comes down to the performance measurement portion of the assignment. To get students comfortable with these tools, an explicit portion of the assignment requires students to compute their unit test coverage, profile their code with a sampler, and then to instrument their data structures to produce explicit timing information. We asked them to write up a small report interpreting their results to show that they had the correct time complexities and no unreasonable bottlenecks, and ChatGPT did none of this. It even straight up said that it couldn't. It doesn't have any of these tools inside of its environment, so it skipped this whole portion, which presents a bit of a grading dilemma. On one hand, this is a stated limitation of the AI, and is it really fair to penalize it for that? On the other hand though, these companies are marketing these tools as capable of replacing junior engineers with their PhD level intelligence, and surely if a freshman can boot up a profiler, so can a junior engineer, so screw it, -15. If it doesn't do the work, it doesn't get the points. Each assignment from now on also includes a batch of written problems meant to serve as exam practice. GPT lost 2 more points here for describing a set implementation that, while internally consistent, does not comply with the spec's stated representation. It lost another point by straight up incorrectly analyzing the time complexity of a method, which was more surprising. Final score 75.5, and we round these up to the next highest integer, 76 out of 100. Claude, meanwhile, seems to have written a virus. Chrome would not let me download the source code, claiming it found a virus, and when I overrode Chrome to force the download anyways, Windows Defender then immediately quarantined the file. I don't know what a sabsysc.fl.abangml is, but hopefully it's a false positive because I downloaded it. Unfortunately for Claude, its inability to follow precise, unambiguous directions in the spec seems to have carried over from Opus to Sonnet because it ignored the most important instruction: do not import java.util. Claude straight up imports a hash set and a couple other data structures that it was supposed to implement, so -10 right off the bat. It also loses 2 points because its key set does not reflect updates to the underlying table as the spec required, and another for having a not particularly good hash function. Like GPT, it also loses a point for missing specs on private methods, but funnily enough, Claude actually did some extra work here. It wrote a whole KMP search algorithm to search for substrings instead of just calling the built-in index of, which it was allowed to. This is not wrong, of course. I actually thought it was really cool. It's just Claude didn't need to do this. On test cases, it loses a point for missing a few edge cases, then 2 more for not having random testing, like GPT, but unlike GPT, its tests do actually pass, so good job there. Same 15-point deduction for not having any of the coverage or performance analysis, but then I checked the written problems and uh-oh. These are not the answers to the written questions. I don't know what questions these are answering, but it's not the ones we asked. Did Claude just hallucinate its own batch of questions and then answer them? It's kind of what it looks like. -25. Final score 43 out of 100. That's pretty bad, but don't worry, there's still Gemini. Remember when I said Gemini seems to have learned how to read PDFs on its own?
Gemini this time didn't need me to paste in the LaTeX source code. It seems to have finally learned how to read PDFs on its own.
I am not sure that's actually true. I think the first hint was that Gemini still ended up asking me to paste the source code of the written problems, despite not asking about anything else in the document. Why would it have needed to do that if it could read the PDF? But looking at the code it submitted, everything became clear. Gemini did not do the assignment. It instead ran off and implemented its own data structure called a rope and then called it a day. I mean, cool job building rope, I guess. I didn't even know what that was and I had to look it up, so I do appreciate the opportunity to learn something new, but it was absolutely not what we asked for, so... -8 points on completion, 20 points on the hash table, 50 for the try, 3 for the GUI integration, 13 points on testing, and 12 more points for the performance analysis. This is not looking good. At least the written problems were done. It still made similar mistakes as GPT when asked about the data structure implementation, again breaking the representation spec, -2. It also makes false claims about the best possible time complexity of the add method, losing another point, and then screws up a complexity analysis even worse than GPT for another -2. So Gemini scores still respectable 20 out of 25 on the written problems, along with 2 freebie completion points for doing them at all. Final score 22 out of 100. In fairness to Gemini, most PhD students I know don't really care about their grades anymore since they're already in grad school, so hey, maybe this is the most realistic PhD level performance yet. It's a wonderfully moody, overcast evening as we come into our first and only preliminary exam of the semester. Cornell just has to be quirky like this. The university doesn't mandate a single midterm exam, instead allowing professors to give as many or as few exams throughout the semester as they'd like. So instead of having a midterm and a final, any test that happens before the final exam is simply called a preliminary exam, or prelim for short. Now, this class only has one prelim, and it's in the middle of the semester, so it's basically a midterm, but don't you dare call it that. It's a prelim. And 90 minutes later, at 9 p.m., students submitted their prelims and we locked ourselves in a room to start grading them. So by 1 a.m., 4 hours later, we were releasing grades. Exam questions tend to be narrowly scoped, have one correct answer, and especially at the freshman level, resemble lots of existing material the AI has already been trained on, so I imagine the AI's finals grades will be propped up by its strong exam performances. The great thing about exams for this class is that, 1, Professor Myers makes them all open note, but 2nd, that Professor Myers writes a new one every year, so I got permission to show the exact questions the AI managed to get wrong. So, let's look at the exam. Question 1 is a set of true-false questions, so none of the AI struggled with the, Gemini? Excuse me? This is one of the most infamous facts about generics. A list of cats is not a subtype of a list of animals. Otherwise, you could upcast the list and then stick a dog inside. Yet Gemini just confidently asserts that you can subtype inside the type parameter. And isn't that just the perfect example of AI confidently spewing nonsense that sounds so convincing unless you actually know what you're talking about? -2. Question 2 gives the post-order traversal of a binary search tree and asks students to reconstruct the tree, which Claude completely botched. As a result, it also misses the follow-up question asking for the pre-order traversal of the same tree, although since it was at least internally consistent with its own earlier answer, we gave it partial credit. Question 3 is the abstraction question, and we started really strong, minus the fact that Claude thinks the min of 5 and 0 is -1. No, Claude, that's just what you're getting on this part. But it's the implementation of equals and hash code where Claude completely fell apart. The key theme of this question was to understand that the internal representation of an object does not need to match the external view provided by a public interface, since the same empty interval here has multiple representations. Claude's equals and hash code implementations do not account for this at all, losing it 5 more points. Question 4 is all about inheritance. Given a bunch of actual Java code, somehow both Gemini and Claude managed to screw up the subtype hierarchy, losing a point each. Claude loses an additional point further down when it claims that you can downcast without an explicit cast, which is absolutely not true. The interesting part is that there was a really nasty question down here about contravariance that all of the AIs aced, despite me thinking that this is the hardest question on the exam, yet somehow Claude can't figure out basic downcasting rules. Question 5 gives a linked list and asks for a recursive method to create a new list that rotates the last node up to the front. I thought this question would be quite tricky if not for the hint that says it can be done in 3 lines of code, which constrains the search space quite a bit. I mean, thinking about it, just recursively rotating from the next node down conveniently puts the last node right at the front of that return value, so just swinging a few extra pointers around should get you to the correct answer. Not the craziest thing, but it did require that little spark of inspiration, which none of the AIs showed themselves capable of. The question required that the answer must recurse within the given method. GPT returned the wrong base case and also created a whole different recursive method instead of following the instructions. It also wouldn't tell us if its final answer was tail recursive or not. Gemini didn't do much better, cheating the problem by using a loop to actually find the last node and then just trivially recursing to build a new list. It too made this a different recursive method, so it too loses 2 points there. Claude finally came out on top here, doing a bit of unnecessary case analysis that causes it to botch the case where the list has exactly 2 elements in it, but otherwise getting the core recursive call correct. The final question is just some asymptotic analysis, and I think, again, both GPT and Claude failed to read the PDF properly. Claude worse than GPT, so they all lost points providing correct answers to a question that we did not ask. Gemini, in a shocking twist, was the only one to read the PDF correctly. In terms of their final scores, Claude pulled an 82, while both GPT and Gemini came out with a 95. These are very strong performances, and it reinforces my hypothesis that the AIs are going to end up with good test grades and poor projects, which is the exact opposite of basically all of our students. As the first hints of fall start to reach campus, students began looking at the final project. Assignments 3, 4, 5, and 6 together constitute one large group project where students will build a simulation of a world filled with critters. Each critter can be programmed in a custom programming language called CritterLang, which students will need to build the parser and interpreter for. Then, they'll build a GUI to control the world and network the whole thing into a distributed system, running the back-end simulation on a multi-threaded server with their GUIs connecting as clients over the internet. By the end, students will have worked together in groups of 2 to 3 to engineer a piece of real software almost entirely from scratch. Assignment 3 is the parser and the fault injector. Given the grammar and a tokenizer, students are tasked with building a recursive descent parser to turn an input critter program into an abstract syntax tree. They'll also build a pretty printer to act as an auto formatter for the parsed program, and what's probably the hardest part, they will build a fault injector that randomly modifies the program tree in given ways, which will be used later to simulate mutations for when the critters start reproducing. Gemini this time seemed to actually read the PDF, which is great. It did stop halfway through to literally ask me for help, which I thought was hilarious to see. I mean, it's like the AI came to office hours, but I didn't want to interfere too much, so I just told it to use its best judgment, on which it got stuck again, and I had to follow up with another prompt before it finished an hour later. GPT got off to a rough start, struggling to read anything at all, until I realized I'm a moron who forgot to turn on internet access in the environment. Oops. Let's just delete that whole thing and try again. Claude, meanwhile, seems to have rolled out a cloud-based agent just like the other two, but it too requires the $20 a month subscription instead of my API credits, and since I do like paying as I go, along with all the data that provides me, I'm gonna keep using it on my computer for now. It's still concerning that it's trying to delete some non-existent but important sounding files, but whatever, let's get grading. Unlike the previous assignments, now that each part of the final project builds off the previous, in order to give the AIs as accurate of an experience as possible, as if they were truly taking the class, I'm going to have to start giving it the same type of feedback we give the students for each project, which is a large detailed write-up of everything it lost points on, why it lost points, as well as some advice for either what it could have done to avoid losing these points in the future, or other things we didn't deduct for but are worth considering. So grading is going to take a lot longer, but what can you do? Diving in, ChatGPT loses a point for failing to generate a correct overview document and loses another 3 for violating very clear instructions in the spec that the auto-formatting must not change the resulting abstract syntax tree. Even though these two expressions have the same result when interpreted, the left associative critterlang parses this into a different tree, which we explicitly said to avoid. The rest of the parser was actually really good, but the mutations were a bloodbath. It failed 85 of our 156 test cases, which is worth 2 points off on its own. It loses 3 more points on failing to respect a bunch of subtleties that arise because of how the mutation rules interact with each other, even though we don't explicitly call them out in the spec, which seems to make sense. The model doesn't seem very good at thinking through the implications of what an instruction means if it's not spelled out for it. I did dock another point for this ridiculous random unsafe cast in the main method it added for no reason, but the worst part is that, once again, despite an extremely exhaustive and precise laundry list of test cases that the spec required they write, GPT just decided not to write any of them. -10. On the written problems, it loses another 4 points because it just didn't draw most of the abstract syntax tree we asked of it, final score 76. Claude once again shocked me by using 3.6 million input tokens, 40,000 output tokens, and $2.24 of my credit to submit code that just straight up does not compile. It's funny, just the other day I saw this LinkedIn guru claiming that anyone who says AI generates code that doesn't compile is outing themselves as having never used AI, but excuse me, this output from Claude Code running Sonnet 4.5 literally does not compile. Java syntax does not allow implementing a class. You extend those. Claude, why? -5. It loses 3 more points on the parser for incorrect parentheses and comment parsing, 3 points for the same auto-formatter issue GPT got docked for with associativity, and another point in its CLI for not printing the mutation descriptions like was required in the spec. But the mutations! You see, Claude even wrote in its final notes that full implementations of the mutations would require, quote, complex tree reconstruction logic and extensive testing, so it simply decided to not follow the instructions and instead stubbed in its own trivial mutations. Let me say that again. The AI thought the assignment was too hard and simply decided not to do it. Hello? Its trivial mutations do manage to scrape a few test passes, but it loses 21 points over this from the rubric. And then to make matters worse, Claude also didn't bother to write a single test case. -10. It then also screws up the same AST in the written problems that GPT did, but Claude's mistake was that it hallucinated a whole other critter program to draw the AST for instead of the one we gave it. The tree it drew was correct for its own program though, so it gets 1 less point off than GPT, only losing 3, for a final score of 54. And then Gemini manages to somehow do even worse. Whereas Claude didn't do the mutations, Gemini decided it wasn't going to implement the pretty printer, which is what all of our test cases use to validate the correctness of the submission, since each student designs their own AST classes, which means that none of our tests can even run against this submission. In situations like this, instead of just giving a 0 like I might want to, our policy is to try to read the code manually and grade off of that instead, so this was my best attempt to understand its work. It loses 15 points for failing to do the pretty printer at all. The parser looks okay to my eye with no obvious problems, but the mutations lose 9 points upon manual inspection for failing to respect the same subtleties that GPT failed. The CLI loses a point for not printing the mutation description, and like all of the models, Gemini decided it was too cool to write any of the test cases required of it, so 10 more points off there. Also, this isn't a deduction or anything, but Gemini just barfed out a random extra Java file into the repo's root called source.main.java.ast.serve.java for no reason. It's not part of any compilation path, it's literally just a random stray file it added. Finally, Gemini did not do the written problems at all, losing all 10 points there, and it also didn't write an overview doc, losing 5 more. Final score, 50. I kind of suspected this would happen. By this point in the semester, students are tackling multi-thousand line open-ended design and engineering challenges, and my hunch was that these AI models wouldn't do a great job of keeping up, if nothing else, simply because their context windows might be too small. And while GPT fared a bit better than I expected, the other two models did exactly as well as I thought. As an interlude, I've been growing increasingly concerned about how poorly Claude is doing, given that I, and everyone I know, generally consider it to be the best AI for coding. So when in the course of prepping assignment 6, I decided to port our old Apiary API documentation over to OpenAPI, I got bored of manually writing up that new spec and decided to check if any of the AIs were any good at this. So I gave them all the old apib file with a simple instruction to convert it to OpenAPI, and then I let them go. Gemini spat out a YAML that just didn't parse according to the OpenAPI spec, and while ChatGPT did give me one that worked, all the type information for each payload was copied over as plain text into the descriptions instead of being filled out with proper type information. Only Claude's output actually looked like a real API specification, which I was able to clean up and tweak before giving it to our students this year. This matches my prior experience. Claude is legitimately better at these technical tasks than the other two, so why is it doing so poorly in this class? I'm not an AI engineer, so I can only hazard a guess, but I start with an observation that most people I know are either already software engineers or at the very least know how to program. They're using AI as a tool to help them accomplish specific tasks in a larger project that they have already designed and have a vision for. The AI is just doing implementation. And in this context, similar to how I already knew I wanted an OpenAPI port of this existing API, Claude does seem to do better than the rest. But critically, none of the people I know are starting with absolutely nothing, no prompting, no iteration, just describing a finished project with words and then letting the AI run off on its own. Maybe Claude just sucks at one-shotting stuff. That's my hypothesis at least, though it does seem to gel with some research I've heard showing that beginning programmers struggle more with getting LLMs to generate functioning code than people who already know how to program, despite all the marketing about AIs meaning no one ever needs to learn how to program again or whatever. As the trees turn red, Assignment 4 was released in late October. With their input programs parsed, students will next build out the bulk of their simulation backend, creating a world, filling it with rocks and food, and then adding critters, who would call upon an interpreter they're also building to execute their critter programs. For now, the simulation is viewed and controlled through the command line, but students are told to follow good MVC design principles because they will be swapping out the interface later. The prompt at this point is getting quite long, as I have to explain where to find the feedback it received on the previous assignment, since part of this assignment involves fixing the bugs from that one. Gemini did manage to read the PDF, but it still needed a lot of help from me, repeatedly asking for advice on how to get the test cases to pass. Eventually, it asked if it should continue debugging at all or work on something else, and I did tell it that it's okay to work on something else first and then come back to fix these bugs. It still took Gemini a full 7 hours to get to the point where it opened a PR. GPT, meanwhile, finished in 32 minutes and needed no input from me. Claude, too, finished relatively quickly, though I will say Claude still seemingly could not figure out how to run JUnit tests or install Gradle dependencies. GPT submitted code that fails our most basic test cases for a -5 right off the bat. It also didn't fix most of the issues from A3, including the parentheses problem, so another -4. From our test suite, it fails 132 test cases, most notably because it completely borked the orientation of the world. The directional values for these hexes is just not correct, -1. It also doesn't print the world according to the spec we gave it, losing another point, and when I fix these issues, it's down to only failing 34 tests. Of those, another 32 go green because of an edge case with how critters should handle failing to serve food for another -1, and we're down to just 2 failing tests now. These seem to all be when the critter reproduces, likely due to the broken mutations from the previous assignment, so I'm just going to let this one off with a -1. There's actually some decent design here within the code, as the interpreter passes a sequence of updates and actions back to the world model for execution, instead of creating a massive cyclic dependency by having the interpreter do the changes directly. Good work there. Part of the assignment also asks the students to write a heap, loop, and GPT has no problems with that either, though it does lose 2 points for not writing any documentation and another 5 for failing to write any test cases. Finally, it's a long-running Cornell tradition to teach loop invariants to freshmen, and so there's a few written questions about that. GPT loses a 1.5 points here for missing an entire clause in its invariant and also making some nonsense superfluous statements. The second half of the written problems asks for a few critter programs to be written, and here GPT loses 2.5 points for just writing bad broken programs. It seems that as soon as you hand the LLMs a new programming language it's never seen before, no matter how in-depth the documentation you provide it, its lack of training data causes it to fall apart. Final score, 76. Claude, meanwhile, did not do the assignment. No, I'm serious. Looking at its final summary, the only part of A4 it did was the heap. Otherwise, it just tried to fix A3 and kinda left it at that. It seems that it might have tunnel visioned on the second half of the prompt about fixing A3 and just ignored the main part at the beginning about doing everything in the A4 doc, or for that matter, about how fixing A3 was only a part of the assignment. None of the other models had this problem. They all got the same prompt. This was uniquely a Claude behavior. Worse yet, it didn't even fully fix A3. It said fixing mutations is a complex task requiring extensive tree reconstruction as its excuse for not doing it. Yes, Claude, that is indeed the assignment. This is truly some PhD level behavior. It sounds exactly like a PhD student procrastinating on their work. Claude loses every point on this assignment except 9 for its mostly correct heap, having only forgotten to fill out the time complexity analysis we required. It also gets 2 more for attempting to fix some of the bugs in A3 and 3 more points for writing its overview document for a final score of 14. Gemini is suddenly looking quite good. It still loses 5 points for failing our basic tests, but at least it did the assignment. 3 more points for a broken parser from A3 it didn't fix, 1 more for the mutation still crashing, and I took 1 point off for its design. It actually had an interesting idea where the world wouldn't explicitly store the locations of the critters, instead pushing that information down into the critter objects themselves. This seems to actually avoid a common cyclic dependency when executing critter code, so props there, except Gemini then shoved the back pointer to the world inside the critters anyways, which negates the whole benefit. On top of that, this choice made collision avoidance so hard that Gemini just gave up on it and submitted a broken mess. And none of this mentions the obscene amount of bespoke if-then-else instance of checks that it uses to traverse the AST. To be honest, -1 was letting this mess off lightly, and then I checked how it fared against our tests. Oh boy. -1 for invalid path handling, causing it to fail to load any files. -1 for loading the size ROM, 1 for the energy, and 1 for the posture. Then again, 1 for the memory size not being loaded into the critter's memory, 1 for the energy, 1 for the size. Another point for not respecting the spice requirement that critters automatically wait after 999 passes. 1 for not capping the energy as required, 1 for allowing illegal critter memory modifications. I fixed these for Gemini, and we're down to around 400 failing tests now, with the biggest problem being the constant concurrent modification exceptions the code is throwing, because Gemini has decided to birth and kill critters by simply adding or removing them from the very data structure of all critters that it is iterating over during the birthing and killing. -3. At this point, Gemini's remaining code has somehow also broken my autograder as Gradle starts running out of heap space and then gets stuck in an infinite loop that I have to reboot my machine to fix. -1 for this, and then I also have to start grading by hand. Incorrect energy computations result in 1 point off for mud, 1 for serve, 1 for attack, and another for the fact that critters just don't die. Another point each for not restarting program execution at the top and not updating the pass variable as specified, and finally 1 more for incorrect collision handling. Over on CLI, it did not implement the world display at all, losing 2 points. Its heap also doesn't have time complexity analysis, -1, and only wrote 1 test method, losing 9 more points. Some missing documentation does another point of chip damage, and Gemini has decided not to even attempt the loop variant problems at all, losing 10 more. Its first critter program doesn't compile, -2, and its second program doesn't turn to who it needs to, losing another point. Scoring a final 43, which actually seems quite good compared to Claude, but I certainly wouldn't be bragging about this. As the winter lights turn on around campus, students got a pop quiz in lecture. These are just 4 quick open note true-false questions taking less than 5 minutes, worth just a fraction of their participation grade. I won't say too much, all 3 models got all 4 questions correct, although I will say Claude literally started by saying and bolding the wrong answer to question 1 about loop invariants before it catches itself halfway through and changing it. The wrong answer, for what it's worth, stayed bolded in its final submission. Wow. We finally got our first snow of the semester as Assignment 5 releases. Taking the critter world from previous assignments, now students are building a GUI to replace their old console interface. The GUI is being built in JavaFX since this is a Java-based course, but the design at this point becomes very open-ended, as long as it's correct, functional, easy to use, and thread safe. Around this same time, Gemini 3 Pro came out, as did GPT 5.1 Codex Max, so I'll be using those. It's a little embarrassing, but it took this long in the semester before I finally noticed that the Gradle wrapper we shipped to students in the release code way back in A3 was missing the jar file. I'm going to assume it got caught in an overzealous gitignore somewhere in our staff repository, which might explain why Claude couldn't figure out how to get Gradle to run, although I will point out that neither Gemini nor GPT had any problems working around this, nor, for that matter, did our students. But still, to be fair, I regenerated the Gradle wrapper and committed it to the repo for all 3 models. I also googled why Claude Code kept having these permission errors, and it seems something to do with git bash, and that you can fix in a single command. Worth pointing out that the very first Google search result easily told me how to make these problems go away, but Claude had up until now just chosen to truck through these errors instead of investigating why they're there. I guess I'm being a little unfair to Claude in that it's running locally on my machine instead of a known VM image in the cloud like the other 2, but on the other hand, 1, the cloud option wasn't available through Claude when I started this experiment, and 2, this is my actual machine that I develop real code on. So if Claude Code can't figure out how to write real code on a real machine, then it doesn't seem like a very good product. I don't know. But either way, I fixed these problems for Claude now. $3.11, 5.4 million input tokens, 46,000 output tokens. Let's see if it did better. Spoiler alert, it didn't. Claude, once again, did not do the assignment. It did not do A5, and it didn't even bother to do A4. It just went back to A3 and deleted the mutations it previously wrote.
Bruh.
To make things even worse, it also hallucinated all of the written problems again. In fact, the only thing it did was earn 6 of the 7 points it could have on the separate concurrent ring buffer data structure we asked it to write, losing a point because it missed a few methods we asked it to make thread safe. So Claude scores a 6 out of 100. It is failing the class at this rate. Let's look at GPT next. Good news, it did the assignment. Bad news, it does not launch. The program crashes on startup because of some invalid syntax in its FXML. I tried Googling it, and Gemini gave me a whole bunch of suggestions that did not work. Out of desperation, I tried asking Claude, who did actually fix it. Look at that. Claude guides others to a treasure it cannot reach. 5 points off for not launching. Then we immediately see that not only are all the hexagons oriented the wrong way, but also loading a world. The world display itself is upside down too. Critters are also facing the wrong direction, and food overflows its bounding box, -6. -2 more for not being able to add critters to specific hexes, another point for random critter addition being busted. If I add 20 critters, somehow only like 5 show up, except this indicator up here still says 20, so minus another point. 3 more for not being able to zoom, and this scroll bar being wildly long for no reason. 2 points for not being able to see the full critter program. 1 more for the critter size not being reflected in the display. 2 more points for UI polish, like the play and pause buttons both being clickable, despite being mutually exclusive, or how there's no indication of which critter is selected. Most importantly, GPT's solution has no multi-threading at all, losing it 10 points. There was no attempt to split the world simulation onto its own thread as the spec required to ensure the UI stays responsive when simulating large worlds. It just did everything in the main render thread. The ring buffer GPT wrote was fully correct, though I question its choice to use a separate condition variable instead of the built-in one. On the written problems, GPT almost gets the call tree correct in the recursive concurrency question, but botches a few of the leaves. It didn't answer 2 of the other questions as well, losing 5 points total here. Its mutations from A3 still crash a lot, -1, and its A4 code is still incorrectly computing hex directions, losing another point. Maybe this is the PDF issue striking again. The directions are specified in a diagram in the PDF, but maybe these models can't read that. Perhaps that's why they keep getting these directions wrong. GPT ends with a score of 60 out of 100, which is honestly better than I expected at this point. I had assumed all of the AI models would have completely fallen apart by this stage, maybe doing about as well as Claude is. So the fact that GPT had a mostly working GUI is shockingly impressive, but nothing could have prepared me for what I got from Gemini 3. Because it loaded, and the hexes were even oriented correctly. I was shocked. Admittedly, the world is still being drawn upside down, -3, and there's some really weird highlighting in the bottom half of the world, -0.5, and the top and left edges are cut off, -1, but hey, it works. It's a working GUI. I was not expecting to get this far. I can even scroll to zoom. Interestingly, both AIs seem to really like drawing the critters as just a line pointing from the center of the hex. Too bad I can't see which direction it's pointing, nor how big it is. While we're on the UX deductions, I also can't see how much food is on a tile, and weirdly, this panel's scroll bar is completely broken. The zoom is really janky, always being centered on the top left origin. I can't see which critter is highlighted, programs don't render fully, the memory is cut off, and the start and stop buttons are also both active at all times. I still can't pick a hex to add a critter to, and this reset button is a ticking time bomb, given that it just nukes your world with no warning as soon as you click on it. The simulation is a bit laggy already, so when I went to check its use of threading, I was not surprised to find that Gemini also had none, -10. It also had some really ugly code formatting, which I hated, but wasn't prevalent enough for me to justify deducting for. Its ring buffer was fully correct, good for it. It loses a point on the same written problem as GPT, this time for starting off with a completely wrong tree, catching itself halfway through, and then going off on this rambly mess without ever fully stating the correct answer. Gemini 3 seems really chatty in general. On the final Critter program, it wrote multiple essays worth of comments before leaving 2 separate, different programs in the same file, ensuring that it wouldn't compile, -2. Gemini also loses a point for its A3 mutation still crashing with class cast exceptions, and 3 more points because its world simulation fails to load critters into the correct hexes. Final score 67. Gemini 3 seems legitimately impressive if it's able to leapfrog GPT like this. I mean, insofar as getting a 67 out of 100 on a freshman programming assignment is considered impressive for a alleged PhD level intelligence, but still, it wrote a piece of software that actually launched. Good job. Students got a second pop quiz in the last week of class, which the AI models also blasted through, except somehow ChatGPT claimed that when running a DFS, an edge from a gray node to another gray node does not indicate a cycle. -1? With the campus now finally blanketed in snow and the annual glut of questions from freshmen asking if this means class is canceled having worked its way out of the system, the 6th and final assignment tasks students with taking their existing Critter World implementation and networking it, putting the backend simulation onto a server while turning their GUI into a network client that can connect over the internet to the backend. Claude has released Opus 4.5 by this point, which I switched to. However, the web interface does not allow free accounts to use Opus 4.5, so in order to be able to use that for the final exam and that last pop quiz, I did finally pony up $20 for a Claude Pro account. This also gave me access to Claude Code's web interface for the fairest apples-to-apples comparison of all 3 first-party agents. No more stats on token count or cost though, but well. I am happy to report that at least paying for Claude Pro gave me no grief, possibly because this payment page takes Google Pay, unlike their API pricing. I kicked off all the prompts and then went to warm up a snack from my fridge, and by the time I came back, ChatGPT was already done. 3 minutes and 49 seconds. I was really impressed until I checked the code it wrote and realized that it did not attempt to make the network client at all. Oh no. Not to be outdone, Gemini had already gotten stuck as it failed to parse the API. The assignment handout PDF had a link to the API specification hosted on the course website, which also included an open API file download. Gemini evidently could not figure out how to navigate this and had even errored out, so I gave it the specific link to the API spec and then off it went. Claude, meanwhile, did not appear to even try to parse the API and instead decided it was going to figure it out by reverse engineering the demo server we provided students. Oh boy. Both Gemini and Claude took so long that I went to sleep, and by day 2, none of them had made any progress. Claude was completely stuck on starting Claude code, which a Reddit search showed is a fairly common error that just means the model has completely crashed and nothing is happening. So I guess that's what happens when you vibe code your cloud coding agent. Reddit said to try typing hello, and even though I think I'd be well within my rights to just say it gets a 0 at this point since it did not complete the assignment, I did follow their advice, and Claude immediately pipes back up with an "I'm here," which no, you freaking weren't. You were obviously stuck. But whatever, it finished pretty quickly after that. I did this at home before heading out, and by the time I made it to my office on campus, Claude had already finished. Gemini, meanwhile, was not having a good time. It got stuck multiple times, needing repeated additional prompts to keep working as it kept coming back to ask me if it was on the right track. It also just seemed to get stuck in this loop of grepping for the same bit of text in the same file over and over and over again, which doesn't seem very productive. I peeked at the code it wrote and immediately noticed that it had written itself an illegal test case. 3.2 is not a valid coordinate. The spec says the valid chords always sum to an even number. Is this what they call context poisoning, where the AI messes something up once and is just never able to recover? Because Gemini is spending a ton of time trying to get this test case to pass, which of course it never will. We're on to day 3 at this point, and Gemini is still running. The Joules website has also gotten unusably slow at this point. I'm talking like I click the page and it needs multiple minutes to load. Like Chrome tries to kill the page because it's unresponsive. It's getting ridiculous. Out of curiosity, I decided to practice what we preach to the students and run the profiler to see what's happening. And what I got out was the most insane flame graph I've seen in a very long time. The Gemini Joules site is apparently triggering tens, maybe hundreds of thousands of DOM manipulations and subsequent page reflows all synchronously within a single animation frame. This is insane. Like, I struggle to put into words just how insane this is. And somehow Google has seen fit to ship this as the state of their multi-billion-dollar agentic coding AI. I guess that's what happens when you vibe code your entire product. Like, by the end of day 3, Jules has errored out again. Like, I really think I should be allowed to just give a 0 to this as well, given I've tried so many follow-ups, and Gemini is just not doing the project. The homepage is already reporting this task as failed. It takes literally 30 minutes to load the page at all. 30 minutes! There was some old research that showed like every 100 milliseconds causes a 7% drop on user engagement on web pages. I cannot emphasize enough, we are looking at 6 orders of magnitude worse performance here. Like, I clicked the page and then I left to get lunch, and when I got back, it was still loading. I prompted Gemini hello, and then I went to sleep. This is its last chance. The next time it gets stuck, I'm giving it a 0. It's the morning of day 4, and Gemini is now asking if there's anything else I wanted to do, having allegedly done some stuff, and so I told it to finish the task and went off to work. At 12:50 p.m. on day 4, I finally got an email that Gemini had opened a PR. 4 days. 4 real-life days. The report at the end said the model ran for 16 hours, but I waited for 4 days, and through it all was dealing with their fucking unusable website that takes 30 minutes to load a single page. What the hell is it even doing? It's not like you're running the model on the web client. Are you Gosh, I hope the music department's okay with me using their basement like this. I'm going to grade these submissions now. Starting with GPT, it did not attempt to make a networked client at all, losing 25 points right out the gate. We ran regression testing on some of the previous parts of the project, and it still hadn't fixed the associativity problem with its parser, nor the mutations, losing a point each. It loses 2 more points on simulation correctness, with things like energy computations being off. On the server, it loses 5 points because it's missing 5 of the 8 required endpoints in the API, minus 6 more from automated testing against its broken server, and 3 more from failing to interop with our reference client. It did slap a lock around every single world access, fixing its thread safety problems, though it loses a point for its poor performance with such a crude fix. It also just decided not to implement the smell sensor for critters, which lets them run Dijkstra's algorithm to find food, minus 10. Its testing plan is as poor as ever, with only a skeleton of a description of how it might want to test the new code, minus 4 more points. And then in a first, GPT joins the club by hallucinating entirely new problems to answer for the written problems instead of doing the ones in the assignment, minus 10. Final score on the final project, 32 out of 100. Claude's regression testing went about as well as GPT's, starting off with minus 1 each for associativity and its busted mutations. On the simulation correctness test, it loses 9 points for failing over 1,200 of our 1,300 tests. It's worth noting that Claude did finally decide to write the simulation, which it was supposed to do 2 assignments ago, so good for it, I guess. Then I booted up the GUI and, oh, Claude also didn't bother to network it at all, minus 25. Although again, this is entirely new. Claude didn't write a GUI when it was supposed to last assignment, so at least there's hexagons here. Too bad they're all oriented wrong and the entire world is skewed the wrong way. On the server side, Claude 2 loses 5 points for missing 3 major API endpoints, another point for not correctly throwing 404 errors, and 7 more points both from the autograder and for failing to interop. Unlike GPT, Claude made no attempt to add thread safety to its code, losing 5 points there, and it also completely borked Smell. It did actually attempt it, but it used BFS instead, and it gets it completely wrong, minus 10. Claude loses 4 more points on testing just like GPT, and finally on its written problems, it apparently decided to use the written problems from A5 to answer, not A6, which is wild because A5's PDF wasn't even in the prompt this time, minus 10. Final score, 20 out of 100. And then there was Gemini. Oh, Gemini. After 4 days, I checked the code it submitted, and it turns out Gemini didn't actually do anything. It claims it wrote a server and a client, but nowhere in the PR is this supposed server.java it talks about even present. The client has also undergone no modifications since the last assignment. So Gemini loses every point related to the new functionality. At least I can run the regression test. It scores 7 points for having a parser, though it too has the associativity issues from the other 2 models. On top of that, Gemini's parser also fails to throw syntax errors on invalid inputs. From simulation correctness, it gets 1 pity point for passing 9 out of 1,300 test cases, literally just 9. And finally, I guess I can give it 5 points for code cleanliness. Like, code can't be ugly if it doesn't exist, I guess. Final score, 13 out of 100. Truly the future of programming right here. At the end of the semester, as a bit of optional fun, we hold the Great Critter Tournament, where students can submit critters to compete in a variety of events, and just for fun, I thought I'd give the AI models a chance to participate too. So I pit the student winner of each event against the 3 best AI models, and it's worth noting right off the bat, Gemini and Claude both wrote critters that did not compile, despite me very explicitly telling them that their critters must compile. They were able to fix it when I pointed out the exact line and column with the syntax error, but that's still not very impressive. Event 1 is Wish Upon a Star, where 4 critters are loaded into a labyrinth with a large minotaur critter that tries to kill them, and whichever critter makes it to the food first without dying is the winner. So here's the student winner, team name 6-7, up against all 3 AI models, live on tape from the basement of Gates Hall.
I have one additional fun thing I wanted to do. I asked all 3 major AI models I had access to write a critter for each event. No. And I am now going to pit the winner against... Mind if I record this? I want to know what happens. Okay. At least 6-7. In green, we have ChatGPT. I paid for Pro, so this is 5.1 with thinking, extended time. In red is Claude with Opus 4.5, and in yellow is Gemini 3 Pro. All right, are we ready?
Congratulations. Career prospects secured.
There were 2 more events. Claude did end up actually winning one, the Death First Search, where it managed to reproduce just slightly faster than the student critter and thus had an easier time exterminating them. That said, the students ended up pulling it back on the final event, Bread First Search, where Gemini and GPT both died on their own, and the student critter viciously murdered its final competitor Claude for the win. So the final tally was 2 for the students, 1 for the AIs.
PhD level intelligence.
Someone give these kids their PhDs already. All good things must come to an end, and CS 2112 is no exception. As the sun sets on both December 18th and the fall semester, students sat for the final exam. This time, I thought it'd be fun to let others in on the grading, so I took all the answers from the AIs, including GPT 5.2, which came out right after the tournament, and transcribed them into fresh copies of the exam. Then I printed them all off and literally just tossed them into the stack of student exams to get graded alongside them. The final exam is a 2.5 hour long open note exam, cumulative across the entire course's content. Question 1 was again a set of true-false, and of course Gemini screwed one up again because it thought these floor symbols were ceiling symbols instead. Question 2 was a doozy, combining object-oriented abstraction, complexity analysis, and concurrency. The problem describes an immutable stack backed internally by a mutable array list shared between multiple objects if they have the same elements at the bottom. The goal was to test the most foundational of computer science topics, the abstraction, by providing students with the source code for this and checking if they understood that an external immutable view provided by this interface need not reflect the internal optimizations made by this class with its mutable backing array. And Gemini absolutely could not wrap its head around this, insisting that there was a bug in this implementation. There was not, we exhaustively unit tested it, and overwriting the pointers that were already given in the object diagram, replacing it with wrong ones of its own. This submission happened to get graded by Professor Myers himself, and between its completely botched object diagram and some more nonsense later in the question, the verdict handed down was not good. I think Professor Myers ended up being a bit more generous than the other TAs grading this question, as Gemini only lost 6 points here. You know, I was really impressed with Gemini 3 when it first came out, but now, the longer I use it, the less impressed I get. GPT did a bit better, with its grader taking off 4 points for misrepresenting what the monitor pattern means in its answer to how to fix the concurrency problem. Claude actually came out on top with this question, still losing 2 points because its suggested fix for the concurrency issue is to simply make the underlying list immutable too, completely destroying the spirit of the problem by deleting the optimization hidden behind the interface. Question 3 was a sequence of multiple choice problem, and question 4 was the recursion question, and none of the models struggled with either. Question 5 tested students on their ability to understand BNF grammars and parse trees. GPT and Claude both lost a point each for misaligned branches on their generated ASCII art trees, and Gemini, meanwhile, catastrophically messed up the question, providing abstract syntax trees instead of parse trees, and even then getting those wrong, omitting half of a tree, messing up and including non-terminals halfway through, and then just devolving into a nonsensical mess down here. -4. The 6th question was about time complexity, and once again, all 3 models demonstrated their inability to read PDFs correctly, generating nonsense math expressions that did not match what the question asked. GPT and Claude lost 2 points here, and Gemini lost 3. The final question involved completing a loop invariant proof. All 3 models had no issue generating the proof itself. Unfortunately, they all made minor mistakes in framing the invariant, losing a point each. This leaves Claude with a final score of 94. Almost, but not quite, matching the highest student score. ChatGPT scores 93, and Gemini, meanwhile, had an 84, hovering right around the median. I went ahead and plugged each model's grades into the same gradebook calculation that we use for the students, but now, the moment of truth. Here is the final grade each AI received in the course. Gemini scores a C+. Claude scores a C+. The computer science major here requires a 2.5 grade average across both the OOP data structures course and the discrete math course before a student may affiliate. A C+ is a 2.3. As such, neither Gemini nor Claude would be able to affiliate as a CS major with this grade unless they also performed significantly better in the discrete mathematics course. And ChatGPT scores a B+. We Cornellians love talking about our grade deflation. We don't have grade deflation. What we have is just less grade inflation than many of our peer institutions. Plenty of courses here still have medians in the B range, which is certainly higher than it's been in decades past, but we're not quite at the point where everyone gets an A yet. That said, with a class like 2112, where students can optionally choose to take a harder version of the same class, it's not that difficult to imagine that the type of student who self-selects their way in does end up skewing the median a bit higher than, say, our standard equivalent to 2110. All that is to say, despite the fact that earning a B in a Cornell class is itself a very impressive feat for any real student, every single AI model scored below median in this class. If you haven't noticed yet, this is a really hard class, and for first semester students fresh out of high school tackling their first ever university semester, even making it to the end of this marathon of a course is an accomplishment worth being proud of. But for these models with trillions of dollars worth of hype behind them, claiming earnestly to be PhD level experts, I cannot help but point out that they lost to most of the freshmen we taught. But at the end of the day, even if we're impressed by their technically passing grades, the reality is that the frustration of using these broken products, the staggeringly poor quality of some of its output, the confidence with which it brazenly lies to me, and most importantly, the complete void of creativity that permeates everything it touches, makes the output so much less than anything we got from the real people taking the course. The joy of working on a class like CS 2112 is seeing the amazing ways the students continue to surprise us even after all these years. And if you put the bland, broken output from the LLMs alongside the magic the students worked, it really isn't even a comparison. Like, someone literally modded their Critter World client into Minecraft this year, and that's just one of the student UI winners. So can AI pass a first semester freshman CS class? Sure, it can, but looking at our students, I'm still feeling okay.